So this is a measurement module. Normally it takes about 15 minutes, 10 minutes. We now had to adapt to the 1535 gauge. And there we don't have all the fittings and so on, so that's why it's a bit too much manual. But in Zurich, where we make the regular measurements, twice a year, it's 140 kilometers with this one. We go out, it takes 10 to 12 minutes. We are on the road and they can go.
Yeah.
We also can measure during tram traffic if it's not too busy.
Yeah.
But better is by night when you drive. So we have basically three sensor systems on here. One is the laser, it's a cross-section measurement. This measure about from here to here. You cannot see it by night, you see it better.
Yeah.
The cross-section. And for the parameters on the rail, we measure, for example, all the characteristics you can extract.
Yeah.
We can measure. So we have profile is very important, for example.
Yeah.
How much wear out you have, side wear out, head wear out. Then you can measure the the gauge width, for example. And you also can measure from here to there and so on.
Yeah.
This is all the trimetrics. This has just been upgraded now. Normally in Zurich they were just interested in gauge and groove depth as main parameters, and we just upgrade now so we can extract
all the parameters.
Yeah. And on Vignol rails, you also can. We are just going to implement the head height measurements, so you can measure the head height.
There's a mirror.
No, we try without mirror.
Okay.
It's ongoing, ongoing development. Yeah.
The same way as they measure the height.
But the second big thing here is the length measurements, as you can see here. So we have a continuous length profile measurement, so we can see all the corrugation, the waviness. We can see very well the joints, if there are joint depressions, or if the welders didn't make it very straight. So we see all this here. We see sometimes all the things which you can see in the length measurements.
Yeah.
So out of this you can derive where you need to adapt your gauge, or where you need to make build-up welding, or also where you need to do corrugation grinding, for example, because it's too much corrugation. We have then, we make pictures. It's a simple camera. Sometimes you have greasing stations, and you see that in the length profile, and then you think, oh, what's there? And then you look at the picture and say, okay, this is a greasing oiling station, or how do you call that? Yeah. So you roughly see it here. We constantly measure, of course, where we are, but we also have a high precision GPS system on here, and it's accurate. I think we tested it in town the first time, really in the big city. Everything was working, and at a little bit open space we go to 2 centimeters, 2 to 5 centimeters accuracy, or 1 to 5 centimeters. When they are very tall building, it goes up to about 50 centimeters. I think the maximum was 70 centimeters or something like that. So we know exactly where we have measured.
Yeah.
This is important if you want to compare measurements from last year to this year. You need to compare apples with apples.
Yeah.
Because the groove depth can vary from. So we take here a measurement every 2 millimeters here. We also have the groove depth is about every 20 or 30 centimeters. Just that we don't have too much data. And the cross section we can adapt. Normally we take every 5 meters. Now in the demo pilot we made every 1 meter.
Okay.
Your lead customer here, or GVB is lead customer. We are setting up a cloud-based services or data storage system, we call it, where you can input all different data types. Perhaps we can go in later on and show something, or drink a coffee. I can show you later on directly on the screen. So the idea behind that is that any data you get on the rail geometry, you can load up. So we have our rail monitor where you can load data up. We have automated interfaces. You just put your sessions in. we have the measurement module. We also have manual length measurement types, but we also have external distributor. I don't know if you know the Calibri system, the Calibri. So we have made now a connection to that, so we can load in data from there. So sonst gebe ich dir mein Bild.
Ja. Moet je maar op cijfertjes aan het analyseren, dat is best wel complex.
Ja. Nee, die Maus kannst du meine steuern.
Maar die PDF's die heb je
Ja.
Nee, ja, aber ich habe so das so.
Okay, sonst musst du mir sagen, wo längst. Wir haben keine Zeit. Wir fangen mit an. Okay, so this is Jan. Yeah, I think you already introduced his IT specialist on this, and we have seen. I forgot to mention. We also have sensors, of course, to measure the handling, and also in this direction. So we have a very high accuracy IMU, inertial measurement unit, which also corrects if you drive through a curve. It automatically corrects the centrifugal force, so you don't have fails measurements. So it's a very accurate measurement. Password.
Adjust the other views for this as well, but now we have here the basically main things that we will discuss. Since you guys in Amsterdam don't have a section and kilometrage, but rather have nodes and
lines and knots.
something about if you were able to do that, and also for like the repairs, like the small repairs, and like a moving average, regardless of the geographical units, is I think very feasible just for that process to identify the bad spots in certain sections. But we at the more strategical maintenance department, we are planning like a renewal program for the upcoming 10 years based on these geographical units. So we're really looking for an aggregation based on these geographical units, because we take these geographical units and plan them. Like, okay, this geographical unit will be renewed in 2020 and this one in 2025. So we're really looking for more than just a moving average, but a moving average based, aggregated per geographical unit. So actually that's a moving average that is resetting all the time. Like every order that it hits on the next geographical unit, it resets. And
okay.
So then because you don't want to overlap the data, you want like to draw conclusions based on every geographical unit.
So you have to.
And the idea behind what we are doing, based on this direction, or this, I think about something like 36% is here, 30% of the data is here, something like 15%, something. I'm not sure about the exact percentage, but about this. And so if you have the value here, which would be like, for example, 60 millimeter of wear, 79.5% of the data is below this point. So you're taking a quite conservative view, but you're also cutting off like the most extreme points. So within all these geographical sections, this way to derive this data point, and we take this as the representative wear of the groove rail. What we subsequently do is that we, with this value, we calculate like a location-specific degradation coefficient. So what we do with